The universe is a vast, mysterious place, and as we continue to explore the far reaches of space, we inevitably encounter new discoveries that challenge our understanding of reality itself. One of the most intriguing possibilities that have been raised in recent years is the idea that our universe might not be the only one. What if our universe is only a small part of something much larger, something far more complex and beyond our wildest imaginations? This is where the concept of the multiverse comes in, a hypothetical reality where many universes, possibly infinite in number, exist side by side, each with its own set of physical laws, dimensions, and even versions of ourselves. For years, the notion of the multiverse was relegated to the realm of theoretical physics, fantasy, and science fiction. However, recent developments in astronomy, particularly the astonishing discoveries made by the James Webb Space Telescope, JWST, have forced scientists to reconsider the possibility that we may be on the cusp of a monumental shift in our understanding of the cosmos. The JWST, launched in late 2021, is the most advanced space telescope ever built, designed to peer deeper into the universe than ever before. It is capable of observing the universe in infrared wavelengths, allowing it to see through dust clouds and gas that obscure our view with visible light. This groundbreaking technology has enabled astronomers to observe galaxies as they appeared billions of years ago, shortly after the Big Bang, providing unprecedented insight into the early universe. In the summer of 2022, NASA released the first full-color images from the JWST, and what they revealed was nothing short of extraordinary. These images were not just beautiful views of distant galaxies, they were a window into the deepest, most ancient corners of the universe, revealing galaxies that appeared far older than what current models of cosmology would allow. For scientists, this was both exciting and perplexing. The existence of galaxies that appear to be much older than the universe itself is a paradox. How could these galaxies have formed so early in the universe's history? If the Big Bang occurred approximately 13.8 billion years ago, as current models suggest, then how could galaxies like Galaxy C13, which appears to have a redshift of Z equals 13.5, exist only 300 million years after the Big Bang? This galaxy, a massive, fully formed galaxy, seems to defy all expectations. According to conventional cosmology, galaxies take hundreds of millions of years to form, yet this one appears to be a fully developed galaxy, complete with stars, gas, and dark matter, much earlier than anyone expected. It's not just one galaxy either, other galaxies with similarly improbable characteristics have been discovered, including galaxies with even higher redshifts, suggesting that the universe may have evolved in a way that we don't fully understand. This discovery has led many to ask, are we witnessing the birth of a new era in scientific understanding? Could it be that the current laws of physics, which have served as the foundation of our understanding of the universe for centuries, are insufficient to explain these findings? Or, as some scientists suggest, could we be witnessing something far more profound, a glimpse into a multiverse? A universe that is not just limited to the observable reality we know, but one that is connected to countless other worlds, each with its own version of space, time, and even reality itself? The possibility that these older galaxies are not from our own universe but instead come from a mirror universe or parallel reality is a theory that is gaining traction. The idea of a mirror universe is not new. It has been a topic of philosophical and scientific speculation for centuries. However, the recent findings of the JWST have given new life to the theory. In a mirror universe, the laws of physics might be similar to ours, but with key differences, perhaps even the very forces that govern the behavior of matter and energy could be reversed. The concept of parallel universes, or alternate realities, has been a staple of science fiction for decades, but could it be that we are on the brink of proving such ideas to be true? Could it be that the galaxies we are observing, which appear to be far older than they should be, are not part of our universe at all, but instead exist in a parallel or mirror universe, where the laws of physics operate differently? One of the most intriguing aspects of this theory is the idea that these mirror universes could be interacting with our own in ways that we don't fully understand. For example, the gravitational waves and cosmic background radiation that we observe in our universe could be the result of interactions between our universe and others. If the theory of the multiverse is correct, then it's possible that the galaxies we are observing with the JWST are not just ancient, but also potentially evidence of a cosmic collision between parallel universes. This could explain why some of these galaxies appear so much older than they should be. Perhaps they have been transported from a different universe, one with its own unique history. This line of thinking opens up new possibilities for what we might find as we continue to explore the cosmos. Could it be that the universe we observe with the JWST is just one small part of a much larger cosmic structure? Are there hidden dimensions beyond the familiar four dimensions of space and time that we experience every day? These questions are not just theoretical musings, they are the questions that scientists are actively trying to answer as they analyze the data coming in from the JWST and other advanced telescopes. One of the key challenges that scientists face is how to explain the existence of these ancient galaxies in the context of our current understanding of the universe. Classical physics, which has been the foundation of modern cosmology, is built on the premise that the universe began with the Big Bang, and that galaxies and stars formed gradually over billions of years. The discovery of fully formed galaxies so early in the universe's history challenges this model, forcing scientists to reconsider the speed at which galaxies could have formed. Some researchers have suggested that the formation of these galaxies could be the result of a phenomenon known as a starburst, where a dense region of the universe experiences a rapid explosion of star formation. While this theory could explain some of the observations, it doesn't account for the larger structures we see in the universe, such as clusters of galaxies and supermassive black holes, that appear to have formed much more quickly than expected. Another explanation that has been proposed is the idea that the universe is much older than we currently believe. Some researchers have suggested that the Big Bang may have occurred billions of years earlier than we previously thought, and that the universe has been evolving for much longer than the 13.8 billion years traditionally assumed. This theory, which is based on modified versions of Newtonian physics and the idea of light fatigue, could potentially explain why these galaxies appear so old. However, the evidence for this idea is still tenuous, and it remains to be seen whether it can account for all of the observations made by the JWST. One of the most compelling explanations, however, comes from the work of British physicist Roger Penrose, who proposed a theory of a cyclical universe. According to Penrose's theory, the universe we observe today may not be the first universe to have existed. Instead, it could be the latest iteration of a series of universes that have emerged from a precursor universe. In this view, the structures we see in our universe, galaxies, stars, and even black holes, may be the remnants of a previous cosmos. If this theory is correct, then the discovery of these ancient galaxies could be evidence that we are not observing the birth of our universe, but rather the remnants of a much older cosmos. While this theory is still highly speculative, it provides a possible framework for understanding the existence of these galaxies. Despite these various theories, one thing is clear: the discoveries made by the James Webb Space Telescope have shaken the foundations of our understanding of the universe. The possibility that we are looking at a mirror universe, or that we are witnessing the interaction of parallel universes, challenges everything we thought we knew about the cosmos. If the theory of the multiverse is correct, then the implications for our understanding of reality are profound. It would mean that our universe is not the only one, and that there are countless other worlds, each with its own unique history, physical laws, and even versions of ourselves. This idea is both exciting and terrifying. If the multiverse exists, then it opens up a vast array of possibilities for what we might find in the future. We could be on the brink of discovering entirely new forms of life, new dimensions, and even new versions of ourselves. At the same time, it raises profound questions about the nature of existence and the role we play in the grand scheme of things. Are we just one version of ourselves, or are there infinite versions of us, each living out a different life in a different universe? If the multiverse exists, then the boundaries of reality are far more fluid and malleable than we ever imagined. As scientists continue to study the data from the JWST and other advanced telescopes, we may be on the verge of a breakthrough that will change our understanding of the universe forever. The discovery of mirror universes and parallel realities could be the key to unlocking some of the most profound mysteries of existence. It could be the beginning of a new era in scientific discovery, one that will push the limits of our knowledge and challenge our very conception of reality. What we find in the coming years could be nothing short of revolutionary, and it will undoubtedly reshape our understanding of the universe, the multiverse, and our place within it. The age of exploration is far from over, it has only just begun.